Hello everyone, welcome back to my third video. In this video, instead of going over power and different stuff like that, I'm just going to do a quick update on my thoughts and process. So over here, you'll see where I had gave you guys the challenge to get the hexagon area based off my previous work I was doing, but I was running into issues with my design, so I ended up switching it. But anyways, as you can see over here, area A was going to be about 4.169, roughly off of the 9.25 and the 8 dimensions. Yeah, I kind of rounded it there by accident. So then I had to make sure to note that there was a 0.2 difference, thus meaning without rounding 45.16. So moving on, I decided more to stick with circles. Just with the material and stuff, thinking of using for the project, and the funnels and all that, circles just seem to be working better, even though there are situational circumstances where there will still be slight gaps where air will escape by. So it is what it is. You know, nothing in the world can be perfect. So got the basic equation for finding the area. So I decided to work more with shipping containers. So if the diameter is 7.4 feet, just to make sure that it fit relatively nicely into a shipping container, we divide that by 2, we get 3.7, and then we bring in pi, 3.14, and then we get 3.14 times 13.69, equaling an area of 42.9866, and then we'll just round that up. So that's our square feet. And then because we want a ratio of 1 to 2, now we have to find the smaller circle. So we take 42.99 divided by 2, we get 21.495. We'll round that out to 21.5. So from there, I was like, well, I would kind of like to know the diameter and stuff for that. So then we do reverse calculation. So then we go 21.495 divided by pi. We get 6.842. We square root that, and we get 2.615 feet. And then we times by 2, and that gives us the diameter of 5.23 feet. So moving on, because we're working with 3D shapes. So I got the big O, I got the little o. Yeah, I was being punny with that. We have off to the left, the intake area, off to the right, the throat area. And then we're like, what's the length? And then we're like ideal angle, ideal slope and stuff like that. So this is all with help of AI, because I'm not the smartest one around, but I try my best to keep learning. So we want to find the radius difference. So we got 3.7 and we got 2.615. So the delta is more or less putting the 2 and subtracting. Thus we get 1.085 feet of inward slope per side. More or less, just think of that as like your roofing, right? The steps kind of effect. Okay, so moving on from there. So we want to figure out the length. So we take from over here 1.085. We divide it by tan of 6 degrees is our ideal that we want to go for. So the tan there is 0.1051. So by dividing the two, it equals 10.32. Yeah, talking with AI kind of gets a little confusing for understanding math. But if it works, it works. So 10.32 times 2 equal plus the rim drive equals blank for the overall length that we are hoping to go with. So we get 20.64 plus the rim drive. Don't ask me how large it could get. I don't build rim drives. If anyone builds rim drives, feel free to give an idea of how large it will be. So I'm guessing around 21, 25 feet or so for this all to work out. So yeah, there we go. That's more or less the video. Not sure what the next video will be about. Could be about adding up the single turbines to being multiple turbines to see roughly the amount of power we'll get from one to say like 360 or so. So yeah, just stay tuned and thank you very much and have a good day.